All right, this week is testing strategies. It's really just testing tips and tricks and things that I think will help you when you're writing your tests. There's not necessarily, and I always feel weird saying this, but there's not necessarily any content this week that's absolutely required, that you absolutely must know. And by that I mean not tied to the learning objectives to pass this class. There's nothing strictly speaking that you need to know, but I'd say that all the content this week is going to save you hours of coding on your homework, especially, specifically writing the tests, of course. It's about testing all week. So this will really help you write your tests, which is probably the part of the course students struggle the most with. Writing the code, that's not too bad. I mean, you made it this far. You know how to piece together some methods. But writing the tests is kind of new territory. So I want to give just more guidance, more help, tips and tricks, really, of really how to organize tests and how to test methods that aren't necessarily the most straightforward to test, just how to approach all of that. There's no task associated with this week, so it's kind of a week made to help you catch up on the tasks as well, which looking at the task 4 submissions, quite a few of you are pretty far behind, unfortunately. Not ridiculously so, I guess, but for passing, I forget the stats off the top of my head. They were fairly bad. But for having passed the expected deadline, I think there were, I want to say 150 or 160 students who have even submitted anything. Luckily, most of the students who have submitted have passed task 4. But it's the ones who haven't even started that I'm really concerned about. If you're banking on the late deadline, got me a little nervous. But anyway, good thing we have a well-timed break week, so y'all kind of get caught up on that. And only, I think, 20 students have submitted Test 5 so far. But, you got till Friday. It is what it is. Test 5, Test 4 got tricky. Test 5 is tricky. I wouldn't wait till the last minute on these. Yeah.
When you suggest the best time to start like the Saturday before, the Monday of
To start a programming test, I would start them after the Monday of when content starts. Like for Test 5, I would have started last Monday, a week ago, if it were me. I know a lot of people aren't going to start that early, but I had all the content that you needed to start Test 5 done by Wednesday. So I would say that at the latest, like Wednesday, you should at least be seriously looking at the document, starting to write your code, and starting to get things together. And to be fair, maybe that is what most of y'all did. You just haven't gotten to the point where you're submitting to Autolab yet. And, I have no way of seeing that. I have no way of knowing that. So to be fair, maybe everybody's on track. I doubt it, but maybe. Yeah.
Anybody submit 6, 7, or 8?
I haven't checked, but probably. There's always a few students who want to get ahead, especially students who retake the course who have those ones already done. They just have to look at the assignment, see whatever changes I made to them, address those, and then submit and get it done with. So I would assume so by now, but I haven't checked. Any questions on any of this is what I'm waiting for. Structure of the course or anything? Besides that, I'm just going to jump into some live coding. All right, today and really all week is live coding, live examples and everything. So we finally got some of it in there in lecture, some live coding, and we're going to get an abundance of it for, last Friday was. This whole week is today and Wednesday. I want to do all live coding, mostly focusing on testing, of course. Friday, I think some of this is going to spill over, just judging by how far I got in the last one. I want to try to get done with all the coding by Wednesday, and then devote Friday strictly to the debugger. I've been able to sprinkle in a little bit of debugger here and there. I want to devote an entire lecture to just debugger, having all the code already written, and then just run the debugger to find bugs that are in the code. And then we actually have some live coding, more debugging, and live coding next week. I only have one day of slides next week. So we get a lot of live coding. All that to say, my point here, when I'm doing live coding lectures, we've only had one so far, so I'll give this disclaimer. I think I gave it last time. But when I give live coding lectures, I'm not on a fixed path necessarily of what we're going to cover. So if there's something you want to see, more so than most lectures, hit me up in chat, raise your hand, do whatever. And I can deviate from what we have planned. On Friday, I wasn't planning to do objects. I was just going to do a tree of doubles, and somebody wanted objects in the other lecture, so I switched to that and did objects. We can make similar changes. I can do completely different examples. If you think the examples I'm doing are worthless, say, hey, I think these are dumb. Let's do something else. I'm open to suggestions for these, especially when we have a whole week. If you have a suggestion today, I might change everything that I was planning on Wednesday and do something else. Yeah.
I was so confused when I came in the last class late because it was just pieces, doohickeys, and like buttons. And I was like, what's going on?
Okay. I don't know what I can do to to change that. Yeah, I don't know. I'll think about it, I guess, but I don't know what I can do to fix that one. Show up on time. Yeah, it was thingamajigs in the last one, and then we did pizzas here. All right. So left to my own devices, if there are no suggestions, I do have, I have tons of stuff planned that I can do, but if it's not going to be helpful, I'm open to suggestions. So I'm going to start with factorial and int. I'm going to write both of these methods using recursion, so just a little foreshadow, spoilers or whatever. I want to write these with recursion where they're not going to be necessarily straightforward, so we're going to rely on the testing to make sure that our implementations are correct. So we're going to focus on the testing for those, of course. We'll get to, judging by what we did last lecture, we'll get to the bank account. I want to get some testing that involves objects because that's a lot of what you have to test in your homeworks. So we'll try to get to the objects fairly quickly. By the end of lecture, we should have a decent bank test written. And then eventually building up to, on Wednesday, the bank class, which is going to have an array list of bank accounts. And we want to write this method, get large bank accounts. That gives me every bank account that has an amount higher than some threshold, and testing this returned array list. We have an array list of objects that's being returned, and we have to test to make sure that array list has all the right values in it. That's getting more to where we're at testing on the homework assignments. That's kind of the test complexity you're asked to test. And then on Wednesday, I think we should be able to get through all this after Wednesday in 2 lectures. This range method, which returns a linked list of integers. How do I test a linked list of integers to make sure it has all the values that we have in it? We already did linked list testing, but we had to do it again for task 5. And just showing better ways, better strategies of approaching that. Right now, most of you are list.getValue, make sure it is what I expect. List.getNext.getValue, make sure it's what I expect. List.getNext, get value, make sure it's what I expect, which is fine. That's what I would expect for task 3. Task 3 was linked list. For deleting a node in task 3, that's what I would expect you to do. But I want to show a cleaner way, a cooler way to do this one. So let's get started with factorial. And how we would test this factorial method, let me go over it just briefly, but factorial, I think we all know what factorial is. It's factorial of n is the multiplication of all values from 1 to n. If n is 0, factorial is going to be 1. And if n is negative, the factorial mathematically is undefined, I believe, right? We're going to define it for something. We don't have to. We could throw an exception. But we're going to define it to be something. I'm just going to choose -1. If n is negative, it should return -1. That's going to be our way of indicating that an error has occurred. -1 is not going to be the valid answer for any factorial. So if we see -1, we know something went wrong, and it's going to be because we gave it a negative value. So let's write some tests, and I'm going to start with the common factorial tests. And how we would normally approach this, we would do assert equals my math. I'm going to start with 2 this time, so it gives my brain some time to warm up to math. I backed myself in a corner in the last lecture. And this is a static method, so simple math dot factorial of 2. And this is how we would probably write our test cases, which for this one, admittedly, isn't that bad. 6, 3, 24, 4. We're going to have our expected output, our input, call our method, and copy and paste this for however many test cases we want. For this one, not too bad. The method's pretty straightforward. But if we want to clean this up a little bit, if we don't want these magic numbers, which in general are something we don't want in our code, it makes our code less readable. Again, for this application, somebody reading this can deduce that this is the expected output and that this is the input for the test case. So it's not terrible, but in a lot of our tests, they very quickly get complex enough that gets cumbersome, or that gets non-intuitive, I meant. So we would add a little bit of extra here. Int input equals 2. Int expected output equals 2. We would do expected output here. We would do actual equals simple math of input, and then do expected equals actual. Like that's how we would write our test case if we want to get rid of the magic numbers, which we generally should be able to, should want to do. With this, again, for this one, it's not too bad. But once things get more complicated, if you're in the habit of using magic numbers, your more complex methods and your more complex tests are going to be very difficult to read at a certain point of complexity. So getting in the habit of not having magic numbers. This 2 clearly is the input to the method. This 2 is clearly the expected output. This is clearly the thing that I'm testing, that what I actually got from the method. And then we're going to assert that what I got is equal to what I expect. And then we have the situation where we have input 2, expected output 2, actual 2, if we want to code up all these test cases. I am here to show you a better way. Could you work with trees and linked lists in these examples? Wow, factorial. Yeah, we're going to get to linked lists on Wednesday, but not necessarily in this one. I can rip through this one quicker than I planned to if this is a little too basic. But I do want to show at least this next part because this is the part that the whole reason why I have this example. Instead of having separate test cases, and we might copy and paste the method like we did last time, but we're going to create a hash map of our inputs to expected outputs. And I'm going to put my test cases in this hash map. So now it's test cases dot put 2, 2. My goal, whenever I'm writing a test cases, I want to make it as easy and simple as possible for me to add a new test case. Here I'm going to have a data structure with all my test cases. I want more test cases. I add more key value pairs to this data structure. Instead of having all this code or potentially all this code duplicated for every test case, I want that code as small as possible. And then when I want to go through my test cases, I'm going to write a loop for int input in test cases.keyset. Expected output is test cases.get input. Get the key at that, or get the value at that key. Call the method to get the actual, and then assert that actual equals what I expected. Now I'm iterating over every test case in this data structure and calling all of them on my method and testing every single test case. And when I want to add a new test case, it's that simple. That's all I have to do to add a new test case is add a new key value pair to this hash map. I don't have any magic numbers. My code's very self-commenting. Everything's very clear here for what I want to do. And actually, let me get rid of common. I split this into 3 separate methods, did common, uncommon, and edge cases. I'm going to jam them all in one method so we can get on to the juicier bits here, especially with linked lists and trees being called for. I want to make sure we can spend a lot of time on, probably still will be Wednesday, make sure we can spend a lot of time on this method. Which, by the way, in the week 9, like I'm going to put everything in lecture coding this week, but in the week 9, there are all these tests, kind of the same content that we covered last semester. You can see the examples we used last semester. In test linked lists, if you study this one, this is going to give you good examples of testing a linked list, as the name implies. I didn't have anything more to add than the name. It's nice and self-commenting. But that gives you a good example of how we can test linked lists. We're going to do something very similar when we test the range method this time. So if you're eager to get to that part, it's there for you. And then we're going to add a few more. I'm going to not trust my brain. I'm trying to remember these, but I'm not going to trust my brain here. Once we get up high enough, 720, I was right on that one. 7 is 50/40. And that should be fine. We went all the way in the previous lecture, and that's the code I pushed to the repo. We did every single possible valid input for the factorial method, which is only up to 12. After 12, at 13, we overflow an integer. So it's not really a valid input that we're going to test for because, what's our code supposed to do at that point? I'm going to cut it right here and go to my more edge cases. I don't know if 1 would be an edge case in this situation. Maybe, maybe not. Depends on your definition. But not quite. 0 certainly is. 0 is an edge case that should return 1, and my code's going to have to do something a little bit different with 0 to be able to handle that. And then my negative values, -1, we're going to say any invalid input should return -1. -2, make sure it still returns -1. Set up my test case. I want it nice and easy to add new test cases. This is about as easy as we can get. 10, 15, 2,000, 1,000,000, and just for fun, and I did it in the other one too, integer.min value. This is the highest magnitude negative integer that's possible to fit in a 32-bit integer, a 32-bit signed integer. So that value, why not? We'll throw that one in there. And there's our test suite. Looks pretty good. I'm happy with it. Let's get on with the method itself. Oh, let's run this first. Stop saying hot swap failed. I think, because I do have 2 of these running. Terminate. That's why I had 2 of them running in the debugger. Bless you. And we fail. We failed the test case. I'm going to run this in the debugger. Now we expect it to fail because the method just returned 0. But I want to run this in the debugger just to show one certain thing. Run this in the debugger, and since we don't have magic numbers, guess what we get to see? Everything. Bless you. We get to see everything. The input at this point in the hash map is 0. I expect the output to be 1. My actual is 0. I can see those very clearly displayed to me. But what I want to point out right here is my input is 0. This test case right here. I set a breakpoint at the beginning of my loop. So that means it's going to stop here at the very first iteration of the loop. So the very first test case that I run into is this one right here. If you're using a hash map to have input to output behavior, remember that your hash map does not care about the order of your elements. There's it's not a sequential data structure. It doesn't care about order. So you might not get your test cases ran in the order that you put them in the hash map. I got this one first, and then I don't know which one's going to be next. It's going to be in some order that it's usually not predictable. So I'm going to get some randomish order. It's not going to be this one, then this one, then this one. It's not going to be the case. So don't be surprised about that. For example, when this is failing on input of 0, don't make the assumption that you passed all these test cases. So just a word of caution if you're setting up this strategy. Let's go write the method quick. If n is less than 0, that's our edge case. Return -1. else if n equals 0, this is kind of an edge case too. Return 1. That has to be hard-coded because unless I come up with some logical way for it to make sense, I'm just going to hard-code it. Else return n times recursive call n minus 1. If the factorial method is doing what it's supposed to be doing, this will return factorial of n minus 1. If I have the factorial of n minus 1, I'm going to multiply it by n, and now I have factorial of n. So I'm going to multiply n times factorial of n minus 1. If the recursion is doing what it's supposed to be doing, well, how do we know if it's doing what it's supposed to be doing? We're going to run the tests. The tests tell me it's doing what it's supposed to be doing. I don't have to think about it. But we do want to think about it, so just quickly, since recursion is still fairly new, what I'm going to do is set a breakpoint at the base case of my recursion, run the debugger again, and, well, I don't want an input of 0, so let me run this until I get to an interesting test case. What I'm going to do is remove my breakpoint here, but I want to see what happens at the bottom of the recursion so I can talk about recursion. But I want to get to a good test case. I'm going to run the resume button. The resume button is going to restart the code, refire up the program, and run until it hits a breakpoint again. Since I have a breakpoint in a loop, I'm going to get the next iteration of the loop, and it's going to skip all of the details in this iteration. So I'm going to keep hitting resume until I get a test case I'm interested in. And I want some decently large positive integer. So let's go with 7. Now I'm going to go set a breakpoint at my base case, hit resume again. We should stop at the base case, and we can see all the recursive calls when n equals 7. So n equals 7, it's going to make recursive calls until n equals 0, and we hit the base case, where we're just going to return 1. When n equals 1, this called factorial of 0, which returned the right value. It was the base case. So it returned 1. We're going to multiply that by n. In this stack frame is 1. So we return 1, which is the right answer. In the stack frame above that, we're going to get the return value of 1. We're going to multiply that by 2 and return 2, which is the right answer for factorial of 2. Factorial of 3, just called factorial of 2, which returned the right answer of 2. We're going to multiply that by 3, return 6. Factorial of 4, just called factorial of 3, which we just saw is going to return the right answer of 6. It's going to multiply that by 4 and return 24, and so on up the whole recursion. Each step of the recursion, each stack frame, is just going to multiply its value of n, and n has a different value at each stack frame. So we're going to end up with n factorial returned after all these stack frames return. All these stack frames do their multiplication, return their value, and we see expected is exactly what we expect it to be. Okay, any questions on this one? Let's keep it right on moving. I'm going to copy this whole thing. Delete a lot of this. And go on to testing the next thing. The next method we have is multiplying two ints. And yes, we could just do return x times y. We're not going to because I want to use recursion some more and give you more examples of recursion. But more so than that, I want to talk about the testing side. We want to test a method that takes two inputs and returns one output, which is a lot of the testing we have to do. We usually don't have just one input-output. And then the question is, how do we set up this same structure? How do we use this hash map? Hash map's great when there's one input and one output. It's key to value. Input to output, easy. What do we do when there's two inputs and one output? We can't use a hash map anymore, at least not simply. It's not as straightforward. So here what I like to do is create an array list. Of test cases. And what I'm going to do is create a new class for testing. I'm going to create a class, multiply test case, that's going to have all the information for one test case of my multiply method. This is going to have both inputs which are going to need types. And the expected, keep missing my types, and the expected output. Give me a constructor. Oh, that's fine. I need getters as well. I'm going to generate my getters. I don't need setters for this. Just the way I'm going to use it, I don't need them. So I'm not going to create them. But I need a constructor. Constructor is the only way, the only way I'm going to set my instance variables. And I think it complains because it wants these to be final. Since they can't change, they might as well be final. I'll add it, but it doesn't matter. It's not going to be like that in the repo. And now my array list of test cases, instead of putting in key value pairs, I can add them to the array list, but I'm going to do it with the arrays.as list because I think it's a little cleaner. Arrays.as list. Take advantage of the fact that I can have one statement that spans multiple lines and add my test cases into the array list one at a time. And then I have to change the way I'm setting up my loop for multiplied test case, in test cases. Expected output is test case dot get expected output. Int input 1 equals test case dot get input 1. Int input 2 equals test case dot get input 2. Actual equals multiply int input 1, input 2, and the rest is the same. And this is where I want to be. I want to be in a place where it's very easy to add new test cases. It's always my goal when I'm writing tests where I want a whole mess of test cases for one thing. I wanted to get it if possible. It's not always possible, especially when we switch to testing objects. It gets a bit more difficult to set something like this up. But I want to get to a spot where it's easy to add more test cases. If I want to add a new test case, I make them here, and I decide what the answer should be. Change my inputs, change my outputs. It should be that simple. To add a test case, I want to get it down to just that test case. What are the inputs? What's my expected output? I don't want to think about anything else. So let's think of our test cases. Let's go 1,000 and 110. And I want to start thinking of my edge cases, my common, uncommon cases. Here there are 4 big cases that I want to make sure I hit. Both inputs are positive, both inputs are negative, and either first or second one is negative. So let's get my negatives in here. 6 times 4. Oops, I didn't do negative. 6 times 4 should be negative 24. Negative 12 times positive 5 should be negative 60. Negative 5 to 7. Negative 7 times negative 9 should be positive 63. And let's do just a couple more for good measure. Negative 100 times negative 100 is positive 10,000. And then we're feeling okay about that. So let's get our next set of edge cases here, which are zeros. We want to make sure we don't have any errors at zeros. So 0, times negative 100 should be 0. 0 times positive 999 should be 0. Some of these numbers don't matter so much as long as I have the 0 in there. A positive times 0 should be 0. A negative times 0 should be 0. And finally, 0 times 0 should be 0. So we got our zeros, every mix of zeros, every mix of negatives and positives. We got some large-ish numbers in here. We got a pretty good test suite. But notice how easy it is for me to add new test cases. If I want to add 10 more test cases here, it might take like a minute. The longest part of the process is me thinking up numbers and deciding, figuring out what the multiplication should be. That's probably the bottleneck of this process now, because physically typing the numbers is pretty trivial. All right, so I have pretty good test cases here. I want to run my test suite. It's going to fail, of course. But now that we have a sequential data structure, I know that these are going to be executed in order. So I do expect this to be 1 times 1. I can set my breakpoint if I want to verify. Oh, I got my other breakpoint still set. 1 times 1 should equal 1, but actually I got 0. Very easy to see everything about my test case since I don't have any magic numbers. Helps the debugger help me out as well. So let's start writing these things. Let's write this method with recursion. And there are a few unique cases for multiplication that I want to handle uniquely. It's going to be difficult to manage them using recursion. And by that, what I mean are my edge cases. If x equals 0 or y equals 0, just return 0. Don't try to process anything. Just return 0. So right there, I got my one edge case if anything's a 0. And this could be easy to write a bug. You might write if x equals 0 or if y equals 0 instead of if x equals 0 or y equals 0. You might only handle one of the cases. So having the zeros in both spots in our test cases, very important thing to test to make sure either one, we have that covered. And then make sure we have this line. That's what that's making sure. Else if, actually just an else. I wasn't so sure about this method if I was going to get it in one shot, so I just went for it in the other lecture, and I ended up getting it. So I'm going to try to write a bug this time, just to show that our test cases do something. So let's do this. So if or else, I want to check two other things. I want to check our other edge cases here. I want to check Boolean. I want to check if x is negative or if y is negative. So x is negative if x is less than 0. Y is negative if y is less than 0. Remember, sometimes I'll write just crappy code, but remember our shortcut, fix my code for me. Makes it look all nice and pretty. Command Option L on Mac. I don't know what it is on Windows. And then if, I'm going to use a fancy thing here, if x negative, I want to know if exactly one of these is negative, then I know my result should be negative. My goal here is to just work with positive numbers when I'm actually doing the math. If one of these is negative and the other one is not, then the answer is going to be negative. And if I compute the answer just using, actually let me set that up. I'm going to use a helper method for my recursion. Int result equals multiply helper. Math.abs. So I'm going to take the absolute value of x, the absolute value of y, and my helper method is going to assume that x and y are both positive. So that's what I want to do. That's what I want to be able to do in my recursion. I want to assume they're both positive, or else I have to handle both positive and negative numbers. It's going to get a little bit messy. So my helper method is going to assume they're both positive, and then I'm going to handle negatives in the first method that was called without using the recursion. I'm going to do that using this little operator here, the XOR operator. We know this from 191. In code, it's the caret sign, shift 6. That's going to be your XOR operator. I have two Booleans, and I want to know if exactly one of them is false or one of them is true. I'm going to XOR them. If I get in this if statement, I know my result is negative. So I'm going to return -1 times result. Else, they're either both positive or they're both negative. In either case, I don't care. I'm just returning result. I'm going to return the same thing. So I'm having this kind of entry point into my method handle all my edge cases, and then my recursive helper method can be a little bit simpler. Now, and I want to choose one of these to be the one that I'm going to multiply by the other one. That sounds meaningless when I say it like that. I just got to show. If y equals 1. So if one of these is 1, I just got to return the other one. So I'm going to choose y to be the one that I'm multiplying x by. So I need x, y number of times. If y is 1, all I'm doing is returning x. Easy day. Otherwise, I'm going to return my recursive call, multiply helper x of y minus 1. So I want to handle one of these x's and then multiply that y minus, oh, my brain. I'm going to get x times y minus 1. And if I slap another x onto here, then I'm going to get my ultimate answer. So this, reasonably should work, right? Let's run our tests. And it doesn't work at all. So let's use our debugger. If we go to one thing using data structures to store your test cases, you kind of lose some information about what went wrong. It's just going to say the only assert that we even have, that's where the thing failed. So when we click on the blue link, it's not going to tell us which test case failed. So we do have a little bit more work. We used assert equals, so we know we were expecting 10. So we can tell that it was this one that failed, but we have to do a little bit of extra work to get there. This is where we might want to add in our hint strings, or for my money, I'm going to use the debugger. This is 1, 1, 1, 1. That one worked the way we expected it to. And then 1 times 10, we expected 10 but got 1. So this is where things went wrong. So I want to back up 1. We can't literally back up in the debugger. So we're going to have to put our breakpoint one line sooner and restart all the way from the beginning. So we restart from the beginning, 1, 1, 1. We know we got this one right. Resume, 1, 10, 10. This one, I want to step into my method and figure out what's going on wrong. I'm going to skip over all this stuff until we get to the part that's horribly wrong, which I couldn't think of where to put my bug, so I just slapped in a 1 right at the end there. Let's go until we hit our base case. And we have 1 times 1, 1 times 2, 1 times 3, 1 times 4, etc. And we know we're getting 1 we saw in the debugger. So why, if this is returning x times 9, so this should return 9, and then I'm going to multiply that by x, which is 1. It looks like I'm going to return 9 instead of 10. And I can easily see my mistake here is that this has got to be a plus instead of a multiply, because I don't want 9 if this, assuming, we always assume our recursive call returns the right answer. If this is going to return 9, what do I need to do to make that the correct answer of 10 here? Well, it's not multiply by x. I got to add x. I got to add 1, not multiply by 1. So we run the debugger, spot the bug, fix the bug, run the tests, pass the tests. So now even if you don't believe me that all this works and that we covered every case and every situation and the recursion works, even if you don't believe any of it, you should be able to look at this and say, well, that's a pretty good test suite. Yeah, we can add more test cases here, but it's a pretty good test suite, and we're passing that test suite. Code's probably right. We got a lot of answers correct here. And if we do want to verify, sometimes it's nice just to watch. Oops. Expected actual looks good. Negative 24, 24. We're getting all these test cases. Okay. Any questions on that? Yeah.
Okay, this is does autograding have like a limited amount of how many test cases you can have with it?
Mm-mm. No.
So if I have like 1,000 test cases, I can feed it to autograded?
Mm-hmm. The only possible limit to the number of test cases in Autolab is if you hit the 3-minute timeout.
Oh, okay.
That'd be the only thing. But you're really only hitting that if you have something going infinite. Or possibly when we get to next week's content, we're testing with files. If you do give very large files, then possibly you could hit that timeout. I had that issue, but I had that issue with my tests running on student code. I was using large files and timing students out, which I scrapped those tests because I'm like, I don't have to worry that much about efficiency. Doing really silly, inefficient things, but that's for 250 to tell you how to do that, how to be efficient. We don't have to worry about that quite yet. All right, any other questions on this one? Yep.
So I was thinking about this. Does the absolute value function, is it bit shift to the right and left to reset the 0 on the signed part?
I think this just uses like actual math. But if you wanted to do it at the bit level, you would AND it with a 0 and 31 ones. You could do a bitwise operation to do the same thing. But they're using the math operators here. And I've said this before in lecture, but it's super useful, worth repeating, is if I think it's Control on Windows, but Command on Mac, Command click, and it'll take you to the definition of any method. Like in your tests, it can even be helpful just within your own code. I'm calling multiply int. Instead of going over here and finding the class that has the multiply int method, Command click, it'll take you right there. I've used that so much, that saved me so many clicks throughout my life.
You can use a ternary operator.
To what?
If you go back.
Like over here?
No, not in the test case, in the actual code. In the if, you could use a ternary operator.
I can't hear what you're saying.
You could use a ternary operation if either the x negative or y is negative, you could use a ternary operation.
Oh, yeah. Sure. Return. Let me do some cut and pasting. Return. Actually, we can get really fancy with this. If anyone who doesn't want to think about this, don't. But we have 1, 1. We can get fancy as hell here. Yeah, if we wanted to condense this code, yeah, we could do all kinds of stuff. We could put this in line with kind of magic and without commenting code and stuff. But yeah, this is a bit much for what we're doing right now, though. but it is something we can do. All right, let's shift gears. Let's get at least the foundation for the class testing, so we can get into data structures on Wednesday. We can test an array list of objects and a linked list of ints next time. Can I use debugger on your failing marriage? You can try. It might help. If you talk about debuggers and you both see the light and just enjoy life more because you have debuggers, it might help. So we have a bank account. We have some methods that we want. I'll at least get these methods. That's where I got to last time. We're timed about perfect compared to where we got in the other lecture. When I write the homework assignments, these tasks now usually don't explicitly state what instance variables you need. It's up to you to realize that, hey, man, I need an instance variable here. Add that instance variable. So the homework description might say, write a class with all these methods. And it's up to you to say, you know what? And this is a bank account. It's going to hold a number and the string of who owns it. So let's have private double money, because why not? Money, private, string. We're going to need to keep track of both of these values. Account holder. We start off with some amount of money. This account holder equals account holder. Check account, this is our, and I'm going to write the methods first for this one. The methods are pretty straightforward, so while I'm in here, I just want to get them done. Check account is our getter for getting the amount of money, so return this dot money. Deposit, this dot money plus equals the amount that you deposited. Withdraw, this dot money minus equals the amount that you withdrew. Transfer, a little bit trickier, but not too much. This dot, here's where we can take advantage, which maybe a lot of y'all aren't quite here yet, so let me show you. Slow down a bit and show you. This is where it helps to just call the methods you already wrote. When you have a method that does a thing and you need to do that thing, call that method. So here, when I'm transferring this much money from this account to this other account, I'm going to do this dot withdraw the amount from this account, and other account dot deposit that amount. I already have methods that do the things that I need. I just got to call both of them. And then is overdrawn. Let's get this dot money. Let's write this one in less than 0.0. It is overdrawn. And music should be starting, but the Spotify API is crushing me here. So let's shift over and manually play it.